Hello, everyone. My name is Tarunjit Singh. I'm a software engineering manager in Mastercard. Today, we will be going over on how Mastercard's Ethoca Consumer Clarity product helps in reducing friendly fraud using Azure Cosmos DB. Before we dive into the presentation, feel free to reach out to me or Geuntae, who is a software engineering lead at Mastercard, for any questions related to this presentation. So let's get started. You might be wondering what exactly is friendly fraud. So friendly fraud is when a cardholder identifies a purchase on their transaction statement as fraudulent and disputes it, sparking the chargeback process. In actuality, though, they or someone else in their household may have made that purchase. This could possibly happen because default transaction details sometimes contains incomplete or incomprehensible merchant information, resulting in the cardholder misidentifying the transaction as fraudulent. So friendly fraud accounts for as much as 70% of all credit card frauds, costing the industry over $132 billion a year. So how do we solve this problem? You might have seen your credit card statements and hoped if you could have some more information on certain purchases instead of the incomprehensible alphanumeric characters. So Mastercard's Ethoca Consumer Clarity provides exactly that information. It gathers data from various sources, responds with a recognizable merchant name, location, logos, even purchase receipts to better identify the transaction you made in the past, reducing the number of chargebacks and saving the time and money for both the clients and the issuer of the card. It also now provides options to manage the recurring subscription that you see in the credit card statements. So you can now pause, cancel, upgrade, downgrade your subscriptions without leaving your credit card app. So how does Azure Cosmos DB helps us? Well, the most important feature of the Consumer Clarity is the low latency data access. We wouldn't want the cardholders to be waiting for the information to load in the app. The challenge for Consumer Clarity is to query a request over a huge volume of data and return the results within milliseconds. To achieve this goal, we use the point read feature of Azure Cosmos DB, which provides SLA of under 10 milliseconds. The volume of data at Ethoca Consumer Clarity has increased over time and now has scaled to multiple terabytes, translating into billions of documents. We have recently doubled the data load, and Azure Cosmos DB was able to scale accordingly with no issues. Ethoca Consumer Clarity has various sources of unstructured data and hence relies on Azure Cosmos DB's NoSQL data support. With many external entities making API calls to our system, there's a need to accommodate the traffic of millions of requests coming in every day. And Azure Cosmos DB has made it possible for us to handle the large number of requests within the specified SLA. There are other features from Azure Cosmos DB that we use, like data replication and failover switching policies. All we needed to do was to configure the policies to make sure the systems are aligned and fault tolerant. Azure Cosmos DB provides guaranteed write availability of 4 nines and read availability of 5 nines. And another great feature that we use is the autoscaling. Using autoscaling, Azure Cosmos DB was able to automatically increase or decrease the RU utilization based on the request traffic while reading and based on the data volume while writing. The out-of-the-box monitoring tools helps us in overseeing the performance statistics and maintaining the system. And we have experienced that the integration of Azure Cosmos DB with native services was very simple using the provided developer tools. At a very high level, the Ethoca Consumer Clarity is a store and retrieve system where the ETL service extracts, transforms, and loads the files which are cleansed by machine learning models into the Azure Cosmos DB. And the API service serves the request from external entities by retrieving relevant information from Cosmos DB and responding back the results. The data loading process is fairly complex in Ethoca Consumer Clarity, but I would like to highlight one of the use cases here. Azure Cosmos DB is able to load high volume of data from multiple ETL worker processes. At peak time, the ETL worker load billions of documents within the 12 to 14-hour time window. Azure Cosmos DB is able to support asynchronous ingestion requests from each of the worker and adjust to the variable number of ETL workers as they scale up and down based on the data volume. Also, the autoscaling feature in the Azure Cosmos DB allocates the number of RUs based on the ingestion volume. This removes any need to manually change in configuration if the data volume is too small or too large. Once the data is loaded in the Azure Cosmos DB, the replication configuration helps in automatic replication of data over multiple geographies and regions. If an instance of Azure Cosmos DB is down, there is an automatic service managed failover switching, which allows the service from one region to point to an instance of another region. Although the guaranteed availability of Azure Cosmos DB is 99.99%, the application is more tolerant with the failover switch functionality. This concludes the high-level overview of how Azure Cosmos DB helps Ethoca Consumer Clarity in achieving its goals. I would like to now pass it over to Geuntae for some technical details.
Thank you, Tarunjit, for sharing the high-level context. Indeed, the Cosmos DB played a critical role making our API to be super fast. I am Geuntae Kim, a lead developer in Mastercard, and I'd like to elaborate our success story, deeply diving into the technical perspective and how we integrated Cosmos DB into our system. Three main objectives we had when we started building our API were, first, application needs to be highly available following the Mastercard API standard. And secondly, to support high throughput, but at the same time to guarantee the extremely low latency for the end users and then their experiences on their mobile devices. Consumer Clarity ecosystem is fully cloud native in Azure, and then leveraging the power of the cloud computing and its scalability. With the microservice design, the lightweight Spring Boot application is able to horizontally and then seamlessly scale within the Azure infrastructure. Furthermore, our RESTful API is fully reactive and then based on the project reactor, which supports non-blocking mechanism and then asynchronous processing of the request. And it did make stateless microservices scale better in a more predictable way. With all of these cutting-edge technologies, not to mention the convenient Cosmos SK for the Java, we are able to achieve our aggressive requirement of building high-functioning API, and which currently shows that on average 20 milliseconds of the end-to-end latency. While the guaranteed backend latency by Cosmos DB is less than 10 milliseconds and 95th percentile, it is a great accomplishment considering it is an end-to-end latency. It may depend on the data and then volume and how to design the Cosmos DB, such as physical partition, logical partition, etc. I'd like to say that Cosmos DB does its job really well and is lightning fast even if the data volume is huge in the database. Let's further look into how API design evolved, arriving at current status. As I mentioned earlier, one of the requirements was to support very high throughput, and our inbound traffic has been increasing tremendously at times. Sometimes hundreds of thousands of the documents are being read from the Cosmos DB in a single second. The key aspect of the design is to leverage the point width capability of the Cosmos DB. Two approaches team deliberated on at the design phase was simplicity with the querying document together versus low latency with the point width. And eventually, we designed our partition key to be unique for the point width to avoid any single queries from being made from the to the Cosmos DB. In order for us to do that, data was replicated with variation, so always the point width can be made is a big one tip at the beginning. Now you may be curious about how we dealt with the fast-growing throughput in our client application. In fact, we figured that when number of documents fetched at a time are not too significant, 25 requests, for example, it is the best to parallelize the point width with the traditional multi-threading model. Then what it could do when the item retrieved together become high. In our case, it is 200 payloads in a single request. Actually, there is a still way to accomplish this, which is backed by a case study and then benchmark from the Microsoft, which is balancing the number of documents and using the read many functionality of the SK. The result may vary depending on the situation, but in our case, we were able to establish the balanced approach of concurrently querying the data in a smaller group, which lowered the both latency and then RE consumption at last. So one lasting core piece that allowed us to be where we are is the Cosmos auto-scaling throughput. Particularly when your API has a fluctuating traffic, Cosmos DB automatically adjusts its scale almost instantaneously as the request volume goes up and down. Not only you get the cost benefit by having auto-scaled throughput, but it adds essential scalability to your solution, which definitely help with the latency and then throughput management. In addition to the API, it might be beneficial sharing our experiences on the data load side, which fundamentally contribute to our overall system architecture. As aforementioned, unique partition key and then point reading the data are the essential components of our low latency API, and it is possible because of this heavy lifting is done on the ETL side. Because of the periodic altering data set, which is large in volume at times, we needed to load the massive amount of data into a new container as quickly as possible. But it was challenging for various reasons. Even though we designed our application highly scalable, as you can see in the screen, accumulating small latencies from the Cosmos auto-scaling made a high impact on the total ingestion time. And furthermore, partitions started to split after reaching out the max storage size, which significantly decreased the write performance. So in such scenarios, the hack was to create the container with the largely provisioned RU, so that predefined number of the physical partitions can be created. This way, we could avoid partitions from being splitted during the entire data ingestion. Another advantage of preserving the partition is that data can be evenly distributed into the old physical partitions, mitigating the hot partitioning as low as possible. With this highly balanced and then concurrent data ingestion architecture, tens of terabytes data could be sent to the Cosmos DB at a very high scale as expected. Before passing this over to Tarunjit back, I'd like to share good customer experiences with Azure team and then Cosmos DB team. Not only it is a cloud database providing high availability, low latency, but MS support team has been really great and then highly responsible in terms of the troubleshooting the production issues. The abundant metrics information both available in Azure portal and then through the SDK as Cosmos Diagnostics also allowed us to build most complex monitoring alerting system, which is another thing to call out before wrapping up my presentation. Thanks for listening, and then over to you, Tarunjit.
Thanks, Geuntae, and thanks to all the viewers for their time. I would like to welcome you to visit at Mastercard's Ethoca Consumer Clarity page to learn more about the product, or you can reach out to us directly. Thank you all. Have a nice day.